everybody. It's been a couple weeks since I've seen you all, and it's been a couple weeks since you've thought about stats at all. So I wanted to give you this first day to kind of have an opportunity to review some of the stuff that we learned about one sample t-test before we get into learning about two sample t-tests tomorrow. So if you haven't yet, give those 4 problems on that review sheet a try. Take out your note packet from before and really work through them and see what you can do on your own. As you get stuck on problems or if you have questions here and there, that's what this video is here for, to kind of help you out. Just to give you an idea of what's coming this week, tomorrow you'll learn about 2 sample t-tests and intervals, and then you'll get a chance to practice on Wednesday and Thursday, and then Friday you're going to do a little at-home open note quiz. On Wednesday and Thursday, I'm planning to have some Google Hangout sort of office hours so that you can get live help from me if you need it. And I'm thinking right now that those will be from 1 to 2 on Wednesday and Thursday. So I'll send out a link to that so you have the code to join a Google Hangout if you're interested. Obviously, no pressure. If you're feeling good about what you're doing, you don't have to show up to that. But I want to give you opportunities for help if you need it as much as possible in these strange times that we're in. So, I'm just gonna go through the 4 questions that were on your review assignment. I'm gonna do it kind of quickly because this is meant to just kind of check your answers or give you a little push if you get stuck. So here we go. We're gonna start with number 1. So number 1 is just talking about sort of those T values and how do you get them when you're going, looking for a T critical or looking for a P value once you have a T score. And so there's kind of a couple of ways you can go about this. You can grab your graphing calculator or if you downloaded that emulator on a computer, that's what I've been using today to do this. You can use inverse T if you have it. Some of you don't. And that goes with your percentage first. Now, for A, it wouldn't be 90%. You would do like the 2 cutoffs. Remember, a 90% center interval goes from 5 to 95. So that percentage would either be 0.95 or 0.05. And then comma your degrees of freedom, which are given. You can also on your calculator do C and D using TCDF. And that you type in with your lower boundary, your upper boundary, and then your degrees of freedom. So I did those ones that way as well. If your calculator doesn't have inverse T, you've got 2 options. You can take out your green packet, or in your textbook, if you don't have a green packet, you should have a textbook at your house. And on page A126, there is a table of T values that's set up pretty similar to the one in the green packet as well. So if you're just unsure where to find those T scores, there's some ideas for you. Pause it, try number 1. All right, so let's go over the answers here. So the T critical value for 90% confidence in an interval of degrees of freedom 17. I was using my textbook because I don't actually have a green packet at home with me, and in the textbook, when I looked that T score up, it was 1.740. Now, if you type in inverse T in your calculator, you'd do inverse T of 0.95 comma 17, and that would give you 1.7396, which is basically the same thing that I got in the book. So either one of those is fine. On B then, same idea. You can use the textbook or the green packet, or you can use your calculator, and you just search up that 98% confidence and 88 degrees of freedom. Okay, in your calculator, you would do inverse T of 0.01 or 0.99, and then comma 88. And those were the answers that I got, 2.364 in the book or 2.3695 in the calculator. You can see I forgot to add a stop in here, so we're, got some answers to see on there as well. So if you use the green packet, it's possible you got something that was slightly off of one of those 2 answers, but they all should be sort of in the ballpark of 2.36 or 2.37, and either one of those answers is just fine. On part C now, you're doing sort of the opposite way. You know that the T score is 2.09, and you want that percentage. You want that P value. And so in my calculator, I would press second vars and do TCDF. Notice that that's a greater than symbol, and so I would do my lower boundary here is 2.09, my upper boundary is 1,000, and then 4 degrees of freedom. So when I type that into my calculator, I get a p-value of about 0.0524, and you can see what I typed into my calculator. I wrote it out for you as well. Okay, and then letter D is a 2-tailed test, and so if I quick draw you a picture of this, it kind of looks like this. Where I'm going from a T-score of 1.78 and above, or a t-score of negative 1.78 and below. And so here's where you're going to calculate your TCDF from 1.78 to 1,000 with 22 degrees of freedom and multiply it by 2 for the two tails. Or you could go from negative 1,000 to negative 1.78 as well. Okay. When I do that, I get 0.0889, and you can see what I typed into my calculator. If you got 0.044, you just forgot to multiply by 2 for it being a two-tailed test. Okay, let's go to number 2. Number 2 gives you a confidence interval. It says it's 95% confidence. We're talking about measured pulse rates of adults. And it goes from 70.887604 up to 74.497011. And so when you're explaining what that software output means, you've got the confidence level, you've got the boundary points of your interval, and I'm just going to write the conclusion basically that I would write with this confidence interval. So I said I can say with 95% confidence that the mean pulse rate of all adults is between those two values in my interval. Okay. Question B is a little bit trickier. To find the margin of error, remember that is what you are adding and subtracting onto your X bar. Okay. The margin of error would be if I found like the center point of that interval, how much do I have to go above it to this number, and how much do I have to go below it to this number? That's the margin of error that I'm looking for. So first thing I need to do is find the center of that interval, and I do that by averaging those two endpoints or figuring out what's halfway between the number 70.88 and 74.49. Okay, so I'm going to take those two numbers and average them. So go ahead and add them up and divide by 2. And that gives me that the center of the interval is about at 72.7. You can see the full number I wrote out. And then basically to find the margin of error, I want to see how far is it from 72.7 to either the bottom or top endpoint of the interval. So I just went to the bottom, I subtracted my center point minus the bottom of the interval, and I got a margin of error of 1.8. That's what I'm adding and subtracting to that center value to get to those endpoints. Okay, my interval that I made was 95% confidence. If I wanted a 99% confidence interval, the margin of error would be, larger. And that is because to get a margin of error, you're taking your test statistic, your t-critical, times that standard error. Okay, and a 99% confidence interval for whatever degrees of freedom is going to be a larger number than a 95% t-critical value. If you think about it, the more confident you are that something is true, the wider an interval you would need to have, right? Just logically, you can think through it as well. And so that's another type of explanation you could use to describe why that margin of error would be larger. And then the last two questions are like a strict phantoms and panic question. So basically, you're going to want to, if you want to take this step by step, pause the video and do each of those phantom steps one by one and check them as you go through, okay? So I would suggest trying this first. You have an example in your notes. We did a couple of these, obviously 2 weeks ago, so it's been a while, but give it a shot and then we'll kind of talk through it on here. So for that P step, I'm trying to define the parameter. In this case, what I'm trying to say something about is the mean credit hours of students. Looking at those 250 students in her class, she thinks they're taking an average of 15 credits. We want to know if it's actually larger than that, okay? That kind of leads me into my next step, which is to write the hypotheses. And so my null hypothesis here is that the mean equals 15, whereas if I look at this question, it says, does it indicate that students are taking more credit hours than the professor believes? And so that alternative hypothesis is a greater than 15. Before you start doing your assumptions and conditions, pause, and you're going to want to type all of these numbers into the L1 of your calculator. And when you do that, that'll kind of, remember you want to make like a histogram as well. We'll talk through that histogram in a minute. But first things first, the first assumption I need to check is that it's a random sample. And that is given to me in the problem. You can see I underlined it up on top. It was a random sample of her class. And then I'm looking at to see if the 24 students in the sample is less than 10% of the population. And so that 24 is less than 10% of 250. That gives me independence from student to student. Not true independence, but close enough. And then the last thing is I'm going to look at that histogram. Now, if you just type these numbers in and press zoom 9, it almost looks like it's bimodal. It's kind of making a strange histogram. So what I did is I pressed the window button on my calculator up at the top. And I noticed it was counting by 1.5 on the X scale. And so what I did is I changed that X scale from 1.5 to just 1. So each one of the bars, like there was a bar to represent everybody with 12 credit hours and a bar to represent everybody with 13, 14, 15. And when you do it like that and then press graph, the histogram sort of looks like this. And then it looks more like it's symmetric and unimodal. And again, that sample size of 24 is pretty moderate anyway. And so as long as there's not sort of like big outliers or big amounts of skew or a huge gap between your modes or anything, you're pretty okay either way. So those conditions are met for me. Drawing in that histogram as well. So I'm going to name my test that I'm about to do. I'm talking about one sample of data. I have one sample of 24 students. And I'm talking about their mean credit hours. So I'm doing a one sample t-test for means. And the degrees of freedom is 23 degrees of freedom. Because it's one less than 24. Then you're going to find your test statistic. Before you do that, you're going to want to find your X bar, which is your sample mean, your standard deviation of your sample of 24, and that N, we already know, is 24. So what you're going to do is go into your calculator again. You should already have your data typed into the L1. And so you're going to press stat, go over to calculate, and one variable statistics. Write down what your X bar and your standard deviation are, and then plug those into that test statistic formula. Okay, so you should have gotten an X bar of 16.625 and a standard deviation of 2.22. And if I type those into my formula, remember you're doing your sample mean minus the mean from your null hypothesis. So 16.625 minus 15 over your standard error formula, which is your standard deviation, divided by the square root of n. So 2.22 divided by the square root of 24. That gives me a test statistic of 3.59. Then next step is to find your p-value. And to do that, I would, in my calculator, do TCDF. Since my test is a upper tail test, I would do from 3.59 to 1,000 with 23 degrees of freedom. And this kind of connects back to question number 1 from this practice. Now, keep in mind, you also have the option to just press stat, go over to the test menu, and just do a t-test. One sample t-test. I think it just says t-test in your calculator. And it'll give you that same exact test statistic of 3.59, and p-value says like 7.74 e negative 4, so I move that decimal place over 4 times to the left. And so your calculator will do that for you as well in the test menu. So kind of up to you which route you want to go on that. Last step would be to write your conclusion. Now you've got a p-value of 0.000774, which is obviously very small, which means I don't think I'm unlucky enough to get the results that I did by chance. That's only going to happen 0.07% of the time. And so instead, I think that something fishy is going on, and I'm going to reject the null hypothesis. I did all these calculations assuming the null is true, but I got something super unusual. So what I actually think is happening is that the null's not true, which means that there's evidence that students are taking more than 15 credit hours. Okay, you're going to use some of these numbers again to do the next question. Now, obviously, I'm not going to reinvent the wheel. I don't need to do P and A again. I already did them for this sample of data, and so I'm just going to skip P and A and go straight to the end step, which is I'm going to make a one sample T interval here. I'm looking for a 95% confidence interval. I want to know how many credit hours they're taking. If not 15, how many? And so I'm going to create that interval. Starts from the sample mean, or the X bar, and then you add and subtract a T critical value times your standard error. And that T critical that I get is for 95% confidence and 23 degrees of freedom. You can use your calculator or the textbook or the green packet again to find that t-critical value of 2.0687. And then when you calculate that interval, again, you could, if you just wanted to, go stat over to the test menu and do a t-interval that way. Or you can math this out from these numbers. But the interval that you get should be from 15.686 to 17.564. And you can see my pen writing out the conclusion below, that standard conclusion for 95% confidence. And this answer kind of confirms my last answer of rejecting the null. Since 15 isn't in my interval, it's not a reasonable value according to my calculations, and that again would lead me to reject it as well. Okay. Hope this practice makes you feel more confident. I do need you to now take a snapshot of the work that you did, whether it's on the worksheet or if you just did it on scratch paper, and upload it to that Google Doc so I know for sure that you're connected to the Google Classroom, you're in the habit here. If I don't see this assignment from you today, I'm going to be in touch tomorrow to make sure that you have everything that you need. I hope that you guys are doing all right. I definitely miss you all, and I will continue to keep making some more videos for you. So, and maybe talk to you on Wednesday or Thursday if you need some extra help. See you later.